All right, we're back again. We're looking at solving two-step equations this time. And before we get started, I want to talk about something that we see all the time, okay, a phrase that we maybe hear all the time. I'm talking about please excuse my dear Aunt Sally. Okay, please excuse my dear Aunt Sally. In other words, the order of operations, PEMDAS for short. And we use PEMDAS just to generally work math. All right, it's an order that we proceed in order to get the right answer, and it matters. It matters what order we use. Okay, so we follow this acronym, and that's generally the order that we go in: parentheses, exponents, then we multiply or divide, then we add or subtract. Okay, that is all exactly backwards when we're solving. The idea when we're solving is that we're undoing the math that has been done. Okay, so math would go forward, solving would go backward. Okay, so the idea is that we're working in reverse. We're undoing, and we talked about this undoing when we were doing one-step problems. We want to undo the math that has already happened. Okay, so we're solving, so we do PEMDAS backwards when we're solving. And what that does is it matters how we solve. It matters how we peel back those layers. Okay, imagine we're dealing with an onion or maybe an orange, and we're trying to expose the insides by gently peeling back the layers around that variable. And we can't do them out of order. I can't get to the inside of the onion unless I start on the outside first. Okay, so this PEMDAS backwards, if you will, SADMEP. We're going to be working to add or subtract first. Then we'll see if there's anything we need to multiply or divide. Okay, so let's get an example going here. Let's say I have negative 9x plus 1 equals negative 80. Okay, the first move I'm going to make here is to divide my paper. In my classes, sometimes you'll hear them say Great Wall of China. I don't know, somebody told him that once and it kind of stuck. So we want to divide our equation on that equals sign. Okay, second thing I want to do here is circle my variable. Circle that variable. That tells me exactly what am I looking for. Okay, if you will, we've located the inside of the onion. And at this point, we're trying to peel off the outer layers. Peel off what's with that variable. What is with x? Okay, in this case, I see two things with x. On the x side of the equals sign, on this left side over here. Two things, this negative 9 and this plus 1. All right, what's happening here? Well, I don't see a symbol between the negative 9 and the x. That tells me they're multiplying here. What's happening with the 1? The plus sign tells me I'm adding it. Okay, I need to undo that. Now, which do I undo first? Do I undo the 1 or do I undo the negative 9? So that's when we look over here to our PEMDAS and we work in reverse. I need to start by adding or subtracting something. I need to start at the bottom and work my way up. So is there anything I could add or subtract to make my life a little bit easier over here? Well, yeah, they're adding 1. So I should subtract 1. Okay, and the rule is what I do to one side, I do to the other. Draw my baseline all the way across my problem. Plus 1 minus 1, we learned about this yesterday. That's going to cancel out. I'm going to drop the negative 9 and the x. I have not worked with those two things yet. Equals, and if I compute this over here, I've got a negative 80, and then I dig a little deeper, right? I'm in negative land, so when I'm taking away, I'm going further away from 0. So negative 81. Okay, that's that answer there. Now I have added or subtracted. I've done whatever was necessary here to get rid of the 1. Now I'm to my next step, which is multiply or divide. Which do I need to do? Well, I don't know. Look what's happening here. Negative 9 times x. How do I know times? Because they're mushed together like a magnet that means multiply. How do I undo times? How do I undo multiplication? Divide. Divide by that negative 9. And what I do to one side, I do to the other. Again, here's my power 1 that I've been looking for. There's my power 1. And that allows me to say I've only got one x left. I can drop that x. Negative 81 divided by negative 9. A negative divided by a negative is going to be a positive. How much? Well, 9 will go into 81 9 times. So my answer is x equals positive 9. X equals positive 9. We can check that over here by plugging this 9 back in where x was. Okay, so let's see. Negative 9 times 9 plus 1. That needs to equal negative 80. If I multiply a negative times a positive, I actually get a negative 81, plus 1. This time I'm getting a little bit closer to 0. I'm coming out of the hole just a tiny bit. So if I have negative 81 plus 1, I know that makes negative 80. And since I got the same answer on both sides, I'm satisfied. Okay. All right, let's look one more time. One more example here. We're going to look at negative 2 equals 2 plus x divided by 4. Okay, negative 2 equals 2 plus x divided by 4. Here I see x, circle my variable, okay, draw my great wall. Here I see a couple of things. I see a 2 that's being added to a quotient or a fraction, okay. I see a 4 that's being divided by, okay, divided from x. Which do I get to deal with first? Well, if we're following our PEMDAS rules, please excuse my dear Aunt Sally, if we're following those in order backwards, I should look to add or subtract first. Okay, add or subtract. Here, this is a positive 2. Okay, here this is a positive 2. So if I want to get rid of it, I want to take it away, I'm going to subtract 2 from both sides. Okay, my move here is going to be subtract because I'm trying to cancel it out. I'm trying to get rid of it on this side of the equation. So I've got 2 minus 2, and does it work? Yeah, that makes 0. That part goes away. Negative 2 minus 2. Okay, I've been digging and I'm going to keep digging in that hole. Now I've got negative 4 equals, drop this part. I haven't done with it yet. I haven't dealt with that at all. X divided by 4. Okay. So I've eliminated things that I could add or subtract. I'm done with that part. Now I'm to my next step in my PEMDAS backwards. I can multiply or divide. What's necessary here? What's happening? X is being divided by 4. So I should multiply by 4. And what I do to one side, I must do to the other. Again, this puts me a 4 on top and a 4 on bottom of a big fraction here. There's my power 1. Okay, the whole idea is that I have 1 left on this side. 1x. Okay, so I'm going to be able to drop my x down. That guy just gets to come straight down the pipes here. 4 times negative 4, that's going to be a negative 16. And I believe that's my answer, okay? In my classes, generally, I have you put the letter on the left side, okay? We know that it's reading the same thing, but sometimes it's helpful to put that letter on the left side, okay? All right, so we want to check. We always want to check, especially if we don't have a calculator. We want to make sure our math is good. So we're going to plug in negative 16 for x. That's getting divided by 4. Okay. So here, because we're just computing and we're not solving, here we want to do PEMDAS in order. We want to start with parentheses. Any parentheses here? No. Exponents? No. Multiply? No. Divide? Yes. We need to divide negative 16 by 4 before we ever get started. Okay, so I'm going to bring down the negative 2 equals. I'm going to bring down the 2, and I'm going to go ahead and divide this negative 16 divided by 4. How much is that? Negative 16 divided by 4. It's going to be a negative divided by a positive. It's going to be a negative. 16 divided by 4 is 4. Okay, so it matters. Again, we're actually doing math here. We're actually just computing numbers. So we want to go in order. When we're solving, we want to go backwards. When we're working math, just computing, we want to go forward. So I divided. Now what? Anything to add? No. Anything to subtract? Yeah. 2 minus 4. I'm taking away something bigger than what I started with, so I know I'm going to end up negative. Negative how many? 2. It matches on both sides, so we're good to go. And that was the subtracting that I had left to do. Okay, so since I got the same answer on both sides of my equation here, when I plugged in what I think x was, I know that I did it correctly on the left side. All right.